Today, we study firm heterogeneity in the model of monopolistic competition and international trade. In the last lectures, we have studied a new trade theory model based on monopolistic competition originated by Krugman. But that model assumed homogeneous firms, meaning that there are no productivity differences among firms within an industry. But in reality, as we will see, that firms are heterogeneous. And also in empirical studies, there are increasing number of studies that use plant or firm level data. And these recent studies have shown that considering firm heterogeneity is crucial to capture some important facts about international trade that we will see later. So there are three main facts about international trade. The first fact is that few firms export. The second fact is that exporting firms are different. In fact, the third fact is that trade liberalization raises industry productivity. And models with heterogeneous firms provide an explanation for these findings and other features of disaggregated trade data. And these facts cannot be directly interpreted using representative firm models. So that is Krugman's model. Because the Krugman model with homogeneous firms cannot explain these facts. So for example, in Krugman model, all firms, so Krugman model assumed that when trade is liberalized, trade is open, then all firms will export. And so the models with heterogeneous firms is pioneered by Mark Meritz in his 2003 paper. So before studying the Meritz model, let's look at some empirical findings using firm level data. Fact one, few firms export. This is based on the study by Bernard, Jensen, Redding, and Schott. They show that overall share of US manufacturing firms that export in 2002 is relatively small at 18% when considering the whole manufacturing, all manufacturing sectors, as shown by this table. So when we look at the aggregate manufacturing, so basically all manufacturing sectors, 18% of firms are actually exporting, and the rest 82% are purely domestic, meaning that serving only in the US. But there are varieties when we look at the specific or individual sectors. So, for example, electrical equipment, appliance, and also computer and electronic product have higher ratio of firms that export. Yeah, 38%. So it's a pretty large share. But when we look at the apparel manufacturing, only 8% of firms are actually exporting. So there are variety among sectors, but yeah, in 2002, when we look at the whole manufacturing sectors, only 18% of all firms are actually exporting. Fact 2, exporting firms are different, meaning that firms that export look very different from non-exporters in a number of dimensions, as reported by US manufacturing exporters' export premia. Export premia is the average percent difference between exporters and non-exporters for a particular firm characteristic. So when we look at the export premia, so if exporters and non-exporters are alike, then there is no export premia. So meaning that the export premia, the value of the export premia should become 0. But when but as we can see from this table, the export premia, it's non-zero. So they are actually positive, higher than 0, meaning that exporters are larger, more productive, more capital intensive, and more skilled labor intensive, and pay higher wages. Fact 3, trade liberalization raises industry productivity. So this is a new source of welfare gains from trade. So in old trade theory, including Ricardian or Hexioli models, the gains from trade is due to specialization according to comparative advantage. And the new trade theory, like Krugman, combination of economies of scale and the expansion of product varieties available to consumers, it's the welfare, the source of the welfare gains from trade. But the empirical analysis of trade liberalization at the firm level, there is an additional source of welfare gains. That it's trade liberalization causes a contraction and exit of low productivity firms, and at the same time, trade liberalization causes an expansion and entry into export markets of high productivity firms. So, therefore, in aggregate sense, there will be an aggregate productivity growth. This is a new source of the welfare gains from trade. This is supported by empirical evidence. For example, Nick shows that 2/3 of the 19% increase in aggregate productivity following Chile's trade liberalization. This occurred in late 1970s and early 1980s, were due to the relatively greater survival and growth of high productivity plants, and the remaining 1/3 was due to within plant productivity gains. And similar findings emerged from a large number of studies of trade liberalization reforms in developing countries. And also, so for developed countries, Treffler showed that after the Canada-US Free Trade Agreement, for industries that faced the deepest Canadian tariff cuts, the contraction of low productivity plants reduced employment by 12%, while raising industry level labor productivity by 15%. So, contraction of low productivity firms, so contraction and exit of low productivity firms, but the industry level labor productivity has increased due to the trade liberalization. So, in summary, there are 3 facts from the empirical analysis. Few firms export. Exporting firms are different, and trade liberalization raises industry productivity. So in order to explain these facts, we need to consider the model with heterogeneous firms. Then let's look at the merits model. The merits original model is the combination of the Krugman's model of monopolistic competition and increasing returns and Hoppenheim's dynamic industry level. But actually, the heterogeneous firms model has 2 key features. One is, of course, firms are heterogeneous, and also there are 2 types of trade costs. One is the usual variable or trade cost, transport cost, or tariffs, or other non-tariff or non-tariff barriers that are dependent on the level of export. But at the same time, there can be some fixed costs of trade in order to set up the production supply chain network and so on. So for export, fixed costs are also important. So although the original model has the dynamics of entry and exit, in order to understand the key insight, it is sufficient to consider a static version of merits model. So we consider the simpler version, very simple or static version of merits model without firm dynamics. So the model that we will study is based on the Helpman's survey article. But for full description of the model, so for those who are interested in the original merits model, please refer to this appendix merits PDF file. But in what follows, we study the static version of the merits model. And we will see that the model explains the empirical facts. Specifically, because of the fixed costs of exporting, only the most productive firms find it profitable to export. So this explains the facts 1 and 2. And since only the most productive firms export, only the most productive firms expand following trade liberalization, whereas the less productive firms are forced to contract. So this explains the fact 3. So let's proceed to the setup of the model. For preferences and demand, we assume that representative consumers' preferences are assumed to be of CES type, where sigma is the elasticity of substitution. So here we consider the continuous the goods are assumed to be continuous, not the discrete. So therefore, so in the previous lecture, we assumed that the number of goods, number of varieties, or number of firms are discrete. So can be countable 1, 2, 3, and so on. But here we assume that the varieties exist continuously. So this might be a bit difficult to imagine, but it's just yeah, similar to the case of discrete goods. So instead of saying the number of goods, we use the measure of the or mass of the goods. So here, omega it's so omega corresponds to the total number of varieties, number of goods. So here we say that omega is the mass of available goods. And from this CS utility function, so as in the discrete number, as in the case of discrete number of products, we can derive the demand function, the demand for individual varieties like this, where capital A is E over capital E over capital P to the power of 1 minus sigma, where P is the price index and E is the aggregate expenditure. So here, so we instead of using the summation, we use the integral. But integral it's has the same meaning, the summation. So for technology and production, as I said, there is a continuum of firms, each choosing to produce a differentiated variety. And variety here, variety is denoted by omega. Unlike the Krugman model, the firms may have different productivity. So each firm discovers its productivity. The productivity is denoted by theta, parameter theta. So each firm discovers its productivity only after it enters the industry. And so each firm knows after entering the market, each firm knows its productivity and its variable or production cost per unit of output. It's given by C over theta. So higher productivity parameter, higher value of the productivity parameter means lower unit cost. So higher productivity means lower unit cost. And C times FD is the fixed overhead cost. So therefore, the small c measures the cost of resources such as the wage rate. And so fixed cost is given by C times FD, and both C and FD parameters, meaning that all firms share the same fixed cost. But as for the variable cost, they may have different marginal costs because of different productivity levels. Higher firms with higher theta means lower marginal cost, lower variable production cost per unit of output. And each firm chooses its price to maximize its profits, subject to a downward sloping residual demand curve with constant elasticity, sigma. And this elasticity of substitution actually is also the elasticity of the price elasticity of demand, sigma. So the marginal revenue for each firm is equal to price times 1 minus 1 over sigma. So as in the previous Krugman model. So marginal revenue is equal to price times 1 minus 1 over sigma, which should be equal to the marginal cost. But here, marginal cost differs among firms and equal to C over theta. So from the profit maximization condition, the first order condition for profit maximization, we have this pricing rule. So price should be equal to C over rho times theta. And here, theta is defined as sigma minus 1 over sigma. So higher productivity firm will set a lower price. and substituting this price into the demand function, and then substituting into the definition of the profit, then we have equilibrium firm profits that depend on its productivity. Here, B is the capital B is defined like this. So this depends on the parameter that represents the level of demand, or the market size, and this rho, which depends on sigma, and C is the cost of resources. So in any case, the equilibrium firm profit is given by this expression, and the equilibrium profit is also dependent on the productivity, firm's productivity. So as sigma is greater than 1, higher productivity firm will gain more profit. So more productive firm with higher value of theta will charge a lower price and will be bigger, larger output, and earn higher profits than less productive firm. So this expression, so let's rewrite this expression by using this capital theta, which is defined as the small theta to the power of sigma minus 1. Then we have equation 1. So so capital theta, it's also the increasing in small theta. Therefore, higher productivity means higher value of capital theta. So therefore, equation 1 indicates that higher productivity firm will earn more profit. And subscript D is the profit earned in the domestic market. And if capital theta is equal to 0, then the pi d is equal to minus CFD, which is, of course, negative. So meaning that a firm with a low value of productivity parameter will not be able to make positive profit. By contrast, if this capital theta is sufficiently high, then the sign of equation 1 is positive. So let's define theta d as CFD over B. So that is theta d, it's the value of capital theta that yields 0 profit. that is pi d being equal to 0. And for firms with productivity levels below theta d will make negative profit. This means that those firms will choose not to produce. Because for these firms, variable profits do not cover their fixed cost. So the variable profit is not sufficient to cover this fixed cost. By contrast, firms with higher productivity, having sufficiently high productivity, which is greater than theta d, will supply their products to the market. And given the productivity distribution, we can calculate the fraction of firms that serve the market as the fraction of firms with productivity above the cutoff productivity, theta d. But here, actually, we don't say about the detail or exact expression for the productivity distribution. So here I just say that from equation 1 and setting this pi d being equal to 1, then we have this cutoff productivity. Yeah, as shown by this diagram. The vertical axis measures the firm's profit, and horizontal axis measures the productivity parameter. So for a smaller value of theta, the profit will be negative. And for higher productivity, the profit will be positive. Then there exists cutoff productivity level, which is basically derived by CFD over B. And for firms with productivity smaller than this theta d, they cannot enter the market or exit from the market immediately. By contrast, for firms with productivity level higher than theta d, they will enter the market successfully and make positive profit. And if we interpret this profit function pi d as applying to sales in the domestic market, and we can also consider the export profit for that firm. That is, let us suppose that firms can sell their products in country L as well. And the demand function for this firm's product in country L is represented by the AL times P of omega to the power of minus sigma. So here we assume that all countries have the consumers in all countries have the same utility function, CES utility function, and the parameters of the utility function are the same. So meaning that the demand elasticity of the consumer in country L is the same in the two markets, that is in the domestic market and the country L's market. But AL might be different from A, which is the market size or demand level in the domestic country. So AL might be different from A. That is, the demand levels are not necessarily the same between the two markets. And as I said, firms incur variable and fixed costs for exporting. For variable trading costs, we assume that the trade cost is of iceberg type. So, meaning that tau units of the product must be shipped from home for 1 unit to arrive in country L. Because during the shipment, some of the products are melted. So therefore, so more than 1 unit of product should be shipped from home. And these variable or trading costs include transport costs, insurance fees, duties, and other impediments that may stem from language barriers, differences in the legal systems, and so on. And so in addition to the variable iceberg trade cost, the firms incur fixed export costs, which is given by C times Fx. So these fixed export costs include distribution and servicing costs in foreign markets. So a firm that chooses to sell in the domestic market, that is the firms with the productivity greater than theta D, can make additional profits from export sales when the firm exports to country L's market, and the export profit can be represented by this equation, which depends on the iceberg trade cost and the fixed export cost. And as sigma is greater than 1, the higher the trade cost, the lower the export profit. And also, this variable export profit is also dependent on the productivity. So higher productivity firms will gain a higher profit, higher export profit. And also, if the productivity is small, then the fixed cost would be greater than the variable export profit. Then the total export profit, the net export profit might be negative. So in that case, that firm cannot export. By contrast, if theta is sufficiently large, then that firm can make positive export profit because it can cover the fixed export costs. So there is a cutoff value for theta, which is, of course, the value of theta that makes pi xl to be equal to 0, or which can be calculated by CFX over tau to the power of 1 minus sigma times BL. So in what follows, let's assume for simplicity that the domestic market size and the market size in country L are the same. So AL is equal to A, and therefore BL is equal to B. And in addition, let us assume that the fixed export costs is sufficiently higher than the fixed cost for domestic production. Then we can obtain that the export cutoff productivity is greater than the domestic cutoff productivity. So as shown by this figure. So this is a case where the pi d schedule given by this blue line, it's steeper than the pi xl schedule, this purple line, as a result of trading costs. So the pi d schedule, it's this blue line and steeper than the purple line because pi d, the slope of pi d, it's slope of pi d is b. By contrast, the slope of pi xl is b times tau to the power of 1 minus sigma, and sigma is greater than 1, so the slope of pi xl schedule is flatter than pi d schedule. And in addition, we assume that FD is smaller than pi to the power of sigma minus 1 times fx. Then we have these cutoff levels of productivity. Okay, so theta xl is greater than theta d, meaning that the firms with the smallest productivity, meaning that the firms with productivity parameter theta between 0 and theta d, they cannot make profit even in the domestic market. So therefore, they should exit from the market. For firms with productivity parameter between theta d and theta xl, so for example, let's look at this productivity level. So in this case, the profit earned in the domestic market is definitely positive, but the export profit is negative. So in this case, this firm find it optimal to serve only in the domestic market and don't export to L countries market. So in that case, the productivity level between pi theta d and theta xl, the firms will not export and only serving the domestic market. And for firms with productivity parameter greater than theta xl, they will make profit both in the domestic market and the market in country L. So in this case, the firm will export to the country L as well as serving the domestic market. And for these firms, so for firms with productivity level greater than theta xl, its total profit. So if there are other countries, other export markets, the total profit of firm with higher productivity than theta xl, the total profit will be the sum of the domestic profit, the profit from the domestic market, and the sum of the all export market, sum of profit in the all export market. So to summarize, the relationship between firm productivity and sales pattern as follows. For low productivity firms, they still choose to close down. For high productivity firms with the value of theta greater than theta xl, they can make money from exporting. Therefore, they choose to serve the market in country L as well as the domestic market. For firms with intermediate productivity levels between theta d and theta xl, they will choose not to export and only serve the domestic market. So this finding shows that exporting firms are more productive than non-exporters, and they are bigger since they sell more in the domestic market and sell in the foreign market as well. So as we can see from this picture, the total profit for exporting firm becomes much bigger than the non-exporting firms. And this result is consistent with the data in which exporters are larger and more productive than non-exporters. And lastly, we analyze the effects of trade liberalization. So let's consider multilateral trade liberalization, which is represented by a proportional reduction of trading costs tau in all countries. So reduction in tau will cause the pi xl schedule to be steeper, meaning that the exporter's profit increase. So compared to the initial situation, the reduction in tau makes this pi xl schedule steeper. So meaning that the cutoff level of theta xl becomes smaller. So reduction in the cutoff theta xl. So this means that because of the trade liberalization, a larger proportion of firms were able to choose to export. But at the same time, so this actually effect it's the effect when all other conditions are the same. But at the same time, there can be general equilibrium effects. And these general equilibrium effects make the pi d and pi xl schedules flatter. So general equilibrium effects include the change in the parameter A, the market size A, and the cost of resources C. So more specifically, a reduction in tau makes the number of exporters to be larger. And the larger number of exporters in the market means a smaller demand facing every supplier. So the more exporters, so more exporters means for each supplier, they will face the smaller demand. So meaning that A becomes smaller. And also, the more firms can export means that more demand for productive resources, such as labor, by high productivity firms. And this can push up the factor prices, so higher cost, higher marginal cost. The smaller market size and higher marginal cost. So these effects can makes the pi d schedule flatter, and also a pi xl schedule flatter. But the formal effect of the exporter's profit increase, formal effect of the reduction in the trading cost, tau, it's so the formal effect outweighs the latter general equilibrium effect. In other words, the general equilibrium effect regarding the pi xl schedule is not too large compared to the direct effect of the reduction in tau. The direct effect makes the pi xl schedule steeper, and the general equilibrium effect makes the pi xl schedule flatter. But the formal direct effect is greater than the latter general equilibrium effect. So therefore, the total effects would be like this. the pi xl schedule becomes steeper, and pi d schedule becomes flatter. Therefore, the new cutoff points will change like this. The cutoff productivity for domestic sales becomes higher, and the cutoff level of the export, cutoff productivity level of export becomes smaller. So the final outcome is lower export cutoff and higher domestic cutoff. So this means that, so for example, let's consider the productivity, the firm with the productivity parameter theta between the former level of theta d and the latter level of theta d. So in this case, for example, if the productivity of firm is in between the previous theta d and the new theta d, this firm could make profit in the previous case. But after the trade liberalization, the firm's productivity is smaller than the new cutoff productivity level theta d. So in this case, the firm, so for this firm, it cannot make the positive profit anymore. So this firm should exit from the market after the trade liberalization. By contrast, for firms with productivity between the pre-trade level of theta xl and after trade liberalization level of theta xl. So, for example, so for this productivity level, so before trade liberalization, this firm cannot make positive profit from exporting. But after trade liberalization, this firm can make the positive profit by exporting to country L. So in this case, this firm will export after the trade liberalization. So after the trade liberalization, so more productive firms can survive, and so the firms which were which is very close to the previous cutoff level cannot survive anymore. But at the same time, more firms will be able to export after the trade liberalization. And as the lowest productivity level to survive becomes higher, the trade liberalization leads to higher average productivity, and output is reallocated toward more productive firm. So as industry as a whole, the average productivity in this industry becomes higher. This is consistent with the empirical facts in, for example, TREFRA. So this is the essence of the merits model. And for detail or full description of the model, including the entry and exit process and also the general equilibrium effects, please refer to this appendix merits PDF. Okay, so yes, so much for today's lecture.